Electroplating is a process which in coating one of metal is deposited from plating coating onto the prepared surface. Electroplating is a main process of environmental pollution. It does not comply with standard B to discharge toxic wastewater and heavy metals. So heavy metals like zinc, chromium, and nickel have effect to surface water and groundwater. So pre-treatment and system design are crucial to protect the environment and public health.
Process flow diagram 2.1 Layout of the plant. First is the collection tank, and we'll use acid or alkali. After that, the oxidation tank will use lime or NaOH. Then chemical precipitation, use alum or ferric chloride. After that, the sedimentation tank and filtration unit so that the water become clean. Next to the activate carbon filter for discharge.
To explain about function process flow, the first one is collection tanks to equalize the flow and organize the contraction of pollutants to ensure consistent treatment. The second one is oxidation tank to remove contaminants through oxidations, a chemicals reaction where substances lose electrons. This process is often part of a broader treatment system that may also include naturalizations, occlusion, and sedimentation. The third is process chemical precipitation tanks to remove contaminants from both municipals and industrial wastewater. It can be used for water softening, heavy metal removal from metal plating, waste, or another wastewater. The next process is sedimentation tanks to separate suspended solid from wastewater in the electroplating. This includes particles of metal, oxidants, and another contaminants. Next, filtration tanks to remove these residual particles using sand filters, gravel beds, or membrane filter. The last is activate the carbon filter. This unit remove organic contaminants, unpleasant odor, color, and any trace to be present.
In field properties, it is high of heavy metals such as zinc, copper, and nickel, and it's also usually acidic due to metal salts and acids used. For effluent properties, we can remove the heavy metals via precipitation, ion exchange, or adsorption. And also for the due to the acidity, we can neutralize via acid or base treatment. For compliance of discharge, we have standard A and standard B. Standard A for applies when discharging into environmentally sensitive areas such as upstream, and also for standard B, it is applies when discharging elsewhere such as public drains or sewers.
In conclusion, the electroplating industry generate wastewater that contain toxic substances such as heavy metal, cyanide, and oil, posing serious environmental and health risks. Many small and medium-sized operations struggle to comply with regulation due to limited resources and expertise, leading to untreated waste entering water bodies. This report highlights the importance of a proper treatment system, including equalization, oxidation, precipitation, sedimentation, filtration, and carbon polishing, to effectively reduce pollutant and meet discharge standard. Investing in better technology, skilled personnel, and strict regulatory enforcement is essential for protecting public health and reducing the industry's environmental impact.